Hey guys, welcome back to AlgoYogi. We are doing binary search series, and our next problem in the list is squares of a sorted array. Let's read the problem. So given an integer array num sorted in non-decreasing order, which means increasing order but not strictly increasing, there could be some numbers equal. That's the whole point of calling it non-decreasing. You know, those fancy things, they replaced it with increasing. All right, everyone wants to be politically or like just correct all the time, so that's why they introduced this word non-decreasing. But anyway, I'm not mad at it. I'm definitely not mad at it. Okay. I'm just acting it out. Return an array of the squares of each number sorted in non-decreasing order. Again, non-decreasing order. Well, anyway, I don't know. So nums here is -4, -1, 0, 3, 4. So by the way, square of a negative number is positive. Square of 0 is 0. Square of positive number is positive. So it's the negative number that makes this problem little complicated. So what we really want to do, even in the end, we want to return squares of these numbers also sorted in decreasing order. So you can't just square every number and then just basically try to just return the same order of these numbers. You can't do that. You have to basically change the order of these numbers based on what they become, what their values become after you square them. So if you see that -4 square will be 16, and 16 is not in the first place no more. It's like in the second last place. So here are our numbers, and once we basically square everything up, that becomes -4 square is 16, 1's 1, 0, 9, and basically 100. It is not sorted, so we'll put it under sorted machine, and then it should return us a sorted array of basically 0, 1, 9, 16, and 100. So this is what we return. But if we do it this way, then it's going to be basically sorting after we have squared every number will be n log n time complexity. Can we do better? Yes, let's do better in our life and here every single day. Okay. All right, so how do we do better? We do better by being good to people. So be good to people, okay? Don't be an ass. So how about we use extra memory? We create basically a result array, and then we have this left pointer in the beginning and right pointer in the end. And I know I should have placed this problem in basically 2 pointers because there is no binary search here, and I don't think even if you can use it anymore. And now I'm like questioning why did I put that in this category. But anyway, right now what we're gonna do is like we just square both these numbers up and we check which one is smaller. Okay, so if you see what's smaller is 4, and let's check like their absolute value or maybe their squared value. Doesn't really matter. Maybe like absolute value would be a little, I don't know, just square both these numbers up, and then whatever is basically smaller, then insert that into our result. Or I would rather say append. It, because appending is a less expensive step than doing insertion, because insertion you have to move. If you're inserting something in the beginning, you have to move everything like shift, so basically it gets reassigned to a completely new memory, so you don't want to do that. You just like append it after it. All right, so in this case you can see 4 is smaller. So what will happen is I will actually we will have to insert it only in this case, right? We will have to, because we want to basically build our result from the back of the array, and this is how we will do it. This is how we will do it. We'll have our result. We will have our result. Oh my god, it just keeps happening. And what we will do is, whichever number is greater, absolute number is greater or square is greater, then we will push it into our result here, and then basically decrement or increment the respective pointer. So r will be basically r minus 1, r will over here, then we compare these two, then basically 4 is greater. So what will happen is we'll insert it basically in the beginning of the array, which will be, now it will be 16 and 100, and then left pointer will basically move l plus 1, which will be over here. So we'll keep doing that until these are equal, less than or equal to. All right, so and then this will basically be of big of log n time complexity and same space complexity. So this will be time and space. All right, so let's do that. I think it will be easy solution. Okay, everything perfect. So as I said, we're gonna have a result array. Now we're gonna do basically left and right pointer shit. It will start with 0 and length of nums -1. Sorry about that. -1. While left is smaller than or equals to r, then we keep going. And how do we basically know which number we need to actually insert is by comparing their squares. So if nums r into nums r is greater than nums l into nums l, the square of r is greater than the square of l. That means they could have been negative. This will result into positive. So that means we will insert res dot insert what? We're gonna insert r because this is greater. And where are we inserting it? Basically at the index 0, in the beginning. And then r is reduced, else is basically you bring down your left one closer, because before we do that we just wanna also insert the square of our left pointer, because now what must have happened is either this left pointer is pointing to the number whose square is greater than or equal to r. So we just want to push that. So here rather than r it will be just l. Okay, looks good. And left you increment, right you decrement, and in the end left becomes greater than r. Then we are done processing all the numbers and we just return our result res. Everything looks good. But yeah, I still stand by the fact that append is a less expensive operation than insertion. Okay, all right, so I think something bad happened, and that was because we forgot about when the numbers basically result, we are inserting it, incrementing perfectly. Is this insert even correct? Like I'm questioning that. Does that 0, like how to insert into array or list in Python? How do you insert it? So insert insert 4 at 1. Okay, yeah, just we gotta, rather than here, we're gonna provide it, yeah, like in the beginning. I really hope interviewers don't mind doing this. If they really mind, we searching up like just these little things, you don't remember them all the time. Like, and this is not a very common operation as well that you like usually use. I wouldn't really consider them like nice interviewers, or like, they really care that you're a problem solver than someone who just trying to mug up this data operations and all. All right, never mind. And then we're gonna just submit it, and voila, basically gets accepted. Let's write down the time complexity, and that is big of n, and space complexity would be also big of n. That's because of our result array. Let's go to AlgoYogi, mark this solved, and see you guys later in the next problem. Until then, you know what I'm saying. I'm so tired.